Now sometimes we want to find volumes without rotating, but because we know that a cross-sectional area always has a particular shape. So suppose I have my curve here, and I want to take slices of my solid. And I know that all of my cross-sectional areas here have a particular shape. What is the differential volume of my thin slice going to be? Well, that's just the area times delta x. So this is a case where I've taken thin slices perpendicular to the x-axis. And I know that all of my slices are going to have the same shape. So the volume, when I add all of these up, is going to be the integral from a to b of a of x dx. Similarly, if I were to take the slices perpendicular to the y-axis, and then my cross-sectional area has some area that's a function of y in this case, and I have delta y here, then the incremental volume of my little slice here is a of y delta y. So when I add all of these up, I'm going to integrate from c to d ay dy. Here are some steps that might help you. Draw the area of the base. You can do the three-dimensional sketch if you're good at it. I'm not. I never will. Draw a representative rectangle. All right, so this is your slice, and it's always going to be perpendicular to x or y, and this is going to be stated in your problem. You have to see the perpendicular to in the problem. Now identify dx or dy. Of course, delta x goes to dx, and delta y goes to dy. Identify your limits of integration based on whether you're dealing with x or y. And then identify your area. Is it a circle? Is it a semicircle? Is it a rectangle? Is it a square? Is it a triangle? What other shapes do we have? Pretty much any shape where you have a nice formula. CIRCLE can be used. Write your volume increment. Delta V is going to be A of x delta x, or delta V is A of y delta y. And then add them up. Let's try one here. Suppose I want to find the volume of the solid given by the lines. F is x minus 1 minus x over 2. You can do this rendering. I can't, so I don't even try. So the function is 1 minus x over 2, and then g of x is minus 1 plus x over 2, and x equals 0. And it states the cross sections are perpendicular to the x-axis, and they're equilateral triangles. We'll get to that in a minute. So perpendicular to the x-axis means after I have my base drawing, I'm going to come and put my representative rectangle perpendicular to the x-axis. Now, as soon as I have this, I know everything is going to be in delta x. So the first thing, let me find my limits of integration. I know I want x equals 0, so at what point right here does 1 minus x over 2 equal minus 1 plus x over 2? So this is when 2 is equal to x. All right, so a is 0 and b is 2. Now, what are my areas? My cross-sectional area is an equilateral triangle. So the area of a triangle, and I'm putting a little triangle down there, is equal to the square root of 3 over 4 times the base squared. Okay, now what is the base? All of the sides are the same. So what is the base? The base is going to be the height of my rectangle. So the next thing I need to do is find the base. So the base equals the height of the rectangle. And that's going to equal f of x minus g of x. Remember, it's always top minus bottom, or right minus left. So in this case, the base is 1 minus x over 2 minus 1 plus x over 2. And so when I distribute, I'm going to get 2 minus x. So I'm just going to put a b here. This is my base. Minus x. Little space. Now, what is the differential volume going to be? Well, the differential volume is just this area of my triangle times delta x. I know I've got a lot of triangles there. So what is the area of my triangle? Well, it's square root of 3 divided by 4 times the base, which is 2 minus x squared, times delta x. This is the volume of one of these little slices here. Of course, the next step, we want to add them all up. The volume itself is going to be the square root of 3 divided by 4 times the integral from a to b of, you could go on and put this all in one step. I messed up. It's always okay to show an extra step. So this is going to go from 0 to 2. 2 minus x quantity squared dx. Now it's just a straightforward, let's see, we could multiply this out, or we could do a u substitution. If we let u equal 2 minus x, du is minus dx, u of 0 is 2, u of 2 is 0. So the volume becomes the square root of 3 divided by 4. The integral of, integral from, from 0, from 2 to 0. And this is what? This is u minus u. Minus u squared du. All right. So this becomes minus the square root of 3 over 4. U cubed divided by 3, evaluate it at 2 and 0. And yes, I know those are flipped, but that's okay. I've got this negative sign out here. You can flip this around if it's bothering you. Any calculus that works at this point in time is fine. You should have done it up here, by the way. So this is the square root of 3 divided by 4 times 3. I can go and factor that out. Times 2 cubed minus 0 cubed. And when I simplify this, I get 2 root 3 over 3.